Hi students, now today we're doing 9.8 line integrals. So exactly what we're going to do is the following. We know from calculus that if I need to integrate the function f of x dx from a to b dx, that's easy, we know, right? Because this is a function of one variable. So we integrate with respect to x and we get the answer. Like what's the integration from 0 to 1 of x squared dx? That's easy. Since the integration is with respect to x and the function is a function of x, we say this is x cubed over 3 from 0 to 1. Then we plug the 1, you get 1 cube, which is 1 over 3 minus 0 over 3, and the answer is 1/3. And this is something we have seen before. What's new today? Instead of integrating over, look what happened here. We're integrated over a line, isn't it? The integration is x from A to B only in this line segment. So what's going to happen today is that we are going to integrate a function of two variables, not only one variable. And to integrate this one, we're not going to integrate it on a line, but we are going to integrate it on what? On a curve C. The question is here, you're going to integrate with respect to who? Is it X or Y? You will notice that it could be X, could be Y, and could be something else, by the way. So here we have to understand today that if I give you a function of two variables, X and Y, the question is you're going to integrate with respect to what? And you have to know that the integration is always going to be along what? Not a line, but a curve, because you have the XY plane. So this is the summary of our objective in this section. All right? To start with, before we start anything, we have to make sure that the curve, we said to integrate the function along a curve, then the curve has to be smooth. What do we mean by smooth? Mean this curve C has to be differentiable and not both of them are equal to 0 at the same time. Okay? On some interval and open interval AB. So first of all, have to be smooth. You know what means smooth? Means there is no cut, there is no jump, there is no gap, there is nothing. And at the same time, there are no sharp edges. Like this curve. If you're driving on this curve, this is very smooth drive, isn't it? There are no sharp edges at all. There is no jump. There is nothing in the way. So this is what we call a smooth curve. So to integrate a function g of xy over a curve, the curve first must be what? Must be smooth. Okay. And what do we do for the curve C actually? Remember, the C can be a function of x and y. So what we're going to do, we're going to parameterize it. Remember from section 9.1, how do we parameterize the curve? We let x equal f of t and y equal g of t, and this will lead to changing our curve from being a function of x and y to a function of t and t only. All right, so the target here is now, I need to learn how to integrate a function of two variables over a curve. To do that, the first thing you have to know is that the curve must be smooth. This curve is not smooth. Do you see how it's going? You're going to go from A to B. So on the way here, there is a sharp edge here. So you have to make a strong, change of direction. And this is not a smooth curve. We know the function here is not differentiable because there are infinitely many tangent lines here. So this is not differentiable. So this, but from A to this point here, it's differentiable and it's smooth. And then the curve C2 is smooth. C3 by itself is smooth. So if I need to integrate my function along this curve from A to B, I have to cut my curve into what? Into piecewise smooth curves. So that's another thing. So if the curve is not smooth, but piecewise smooth, we can integrate what? Piecewisely. So we're going to cut the integral piece by piece, and that will make it easy to integrate. Because we have to make sure that always, when I integrate over the curve has to be smooth. C is closed curve, but not this kind of curve is called a smooth curve, closed curve actually, but it's not actually here simple curve. Why is that? Because if you start from A here and you're going to go all the way, like in this direction, and come back again, on the way you're going to cross this one. This is not acceptable to integrate the curve over integrate the function over this curve. So what should I do? I should find, a way to split it and then integrate it over these two curves. This C is a simple closed curve. What do you mean simple? You don't intersect. There is no intersection. You go straight from A, for example, in this way, and you continue all the way. You come back here. There is no gaps in the middle. There is nothing in the middle, but it's closed because you came back to the point that this is. So this is another type of closed curve. This is closed but not simple. And this is closed and simple curve. We like these kinds of curves, and we're going to deal with these kinds of curves where you start from a point and you come back to the same point. All right. Now the question is, how do I integrate a function of two variables over a curve? So we're going to integrate this one over a curve. So what do we do, guys, here? We will actually parameterize x and y by changing x to any function of t and y to any function of t, where t is going to be some from a to b. You will see that you will be able to determine the value of a and b after you parameterize the curve. Okay, so the first method to integrate a function of two variables, which is here g of xy, okay, over a curve. One way to do it is to parameterize the curve. What's going to happen in this case? This will eliminate x and y, and you will have just the integration over what? One variable, which is t, and now I can integrate it the same way I did in calculus. All right? So how do I integrate? So this would be a question. I need to integrate the function g of xy over the curve c. Now, as I said, we don't know we're going to integrate with respect to who. So let's start by integrating the curve, the function with respect to x. So x now, and how are we going to do that? Remember, we're going to parameterize x and y. So x will be what? X will be f of t, and we said y will be what? G of t. Now, then what is dx here? Remember, if x is f of t, differentiate dx over dt is what? The derivative of f is f prime. Bring dt here. So that means this dx will be what? Will be f prime of t dt, which is exactly what you have here. And then you integrate the function. Look what happened. We have an integral over what? Over t only. And t is from a to b. As I said, you will be able to figure out what a and b easily from the curve. What if I need to integrate over y, not x? Same thing. We replace x with what? With f of t. And y with what? G of t. Now, y is g of t. What's the derivative of y with respect to t? It's g prime of t. Bring dt here. So dy is what? G prime of t, which is here. So this dy is g prime of t dt. And this is how you do it. And by the way, you don't have to memorize any of this. It will come by default when you do the question. You will see that this is not something to memorize. Step number 3. I can integrate the function over both x and y, by the way, over the whole curve C, the whole curve C. And if you know, C has a beginning and end. Because the curve C has a beginning of end, then remember, it has what? It has length. I don't know if you remember the length of the curve. We had it in 9.1. This is the length of the curve. This is the formula for the length of the curve after I parameterize it. Okay, now ds, I'm going to notice here that s is a function of t, right? So I'm going to differentiate with respect to t. Remember, when you differentiate this integral, what's going to happen here? The integration is going to cancel the integral, and I'm going to end up with what? What's inside the entity of the integral. Bring now dt here. So now f ds will be what in this case? It's the square root of f prime square plus g prime square dt. This is the only formula that you have to remember and memorize in order to solve the question. So now, one way to integrate a function of two variables along a curve C is that to parameterize the curve C. After you parameterize the curve C, you have 3 ways to integrate. The first way is to integrate with respect to x, number 1. And I showed you how. You can integrate it with respect to y, and we showed you how. And you can integrate it with respect to the whole curve, which is ds, and we saw that this is the formula for doing so. All right, guys? So this is the first way to integrate function of two variables. Let's take this example. It says integrate this one. So I need to integrate 2x x, y, dx, where here along C, and C now is parameterized like this. X is 5t. So what is this, guys? This is f of t. And I'm going to replace y with what? With g of t. This is our g of t. All right now. So what do we do? Very simple. Along the curve C, look what we do. We're going to say the following. So this is equal to 2. Then x will be replaced with what? 5 cos t. Y will be replaced with 5 sine t. How about dx? Let's look at x, guys. X here is 5 cosine t. Differentiate it. So dx over dt is negative 5 sine t. Bring dt here, as I said in the previous slide. So this is minus 5 sine t dt. So dx is negative 5 sine t. So I'm going to replace this dx now with negative 5 sine t dt. Let's remove that bracket. It came here by default. Okay, and the bracket should be here. All right, now. So now look what we do. We are integrating with respect to t. He's telling me just integrated from 0 to pi over 4. So this is from 0 to pi over 4. By the way, let me show you how the curve looked like here. You know, x is what? X is 5 cosine t. Let me show you something here. It's interesting to see how the curve come up to be. You have x is 5 cosine t, and y is 5 sine t. What happened if I square and add? Remember what we used to do before? Square x and square y and add them. So what's the sum of this? This is going to be 25 cosine square t plus 25 sine square t. We can take out the 25. So what am I left with? Cosine square plus sine square, which is 1. So what do we have actually? We have x square plus y square is equal 25. What is this? This is a circle of radius 5, isn't it? So this is the curve. Circle of radius 5. See the curve? Now I was able to see it now. But he wants it only from 0 to pi over 4. So just from 0 theta to pi over 4. This is 45 degrees, right? So this is pi over 4. So which part of the curve I need? I need only that part, just from 0 to pi over 4. So by the way, this is my curve, just this one. This is C. I want to integrate this function along only that C. You see now? Very nice to understand where is the curve C. From the parameterized functions, x and y, I was able to come up with what do you call it? Standard function. And I know this is equation of a circle of radius 5. I graphed it, but he wants it only from 0 to 2 pi over 4, which is actually going to be just that piece of the curve. All right. So now we can finish the integration. What do we have here? 5 times 5 is 25. Times 5 is 125. Times 2 is 250. And there's a minus. So this is minus 250. Integration from 0 to pi over 4 of cosine, sine. So this is going to be sine square t cosine t dt. Let me show you how do we integrate this one, by the way. Remember, look at inside the square. What do you have? You have sine. What's the derivative of sine? It's cosine, isn't it? So let u equal sine t. So what's du? It's cosine t dt, right? So the integration of sine square t times cosine t dt, my question here, I want to integrate this, is what? This is nothing but, I took sine to be u, so this is u square. And cosine t dt is nothing but du. So what's the integration of that? U cubed over 3. And u is sine, so the answer is sine cubed t over 3. And actually, you can do it faster than this way. Look what happened. I have the power 2. What's inside the power is sine. What's the derivative of sine? It's cosine. If you have a power function, guys, look inside the function. If the derivative of the inside exists in front of it, is multiply with it, that's it. Increase the power by 1 and divide by the new power. So this is sine cube t over 3, period, from 0 to pi over 4. And we say now, so this is negative 250. Now what do? We plug pi over 4. So this is sine cube pi over 4 divided by 3 minus sine cube 0 over 3. But we know that sine 0 is 0, so this is gone. So the final answer is negative 250 over 3. Sine cube, sine pi over 4, by the way, is 1 over root 2. So this is 1 over root 2 all cube. Use your calculator to get the answer. And I think it should be easy to find. And the solution is minus 29.5, by the way. So the final answer is minus 25.9. Sorry, 29.5. By using calculator, of course. And if you're not allowed to use calculators, then you can just leave it the way it is. All right, so this is how you solve this question by parameterizing the curve. Let's look at this example. Same one, but now I need to integrate with respect to y. So what do we say? Same idea. 2xy dy along the curve C. It's equal to, by the way, it's the same small c that you see a minute ago, the same curve. But we're going to integrate with respect to y now. So what do we say? This is equal to 2. What's x? 5 cosine t. What's y? 5 sine t. What's dy now? Look, y is 5 sine t. So dy over dt is 5 cosine t. Bring dt here. So dy is equal to 5 cosine t dt. So now here, 5 cosine t dt, this is dy. Done. And he says from 0 to pi over 4 only. Interesting. Same thing. So what do you get? You get 250, but now it's positive. Integration from 0 to pi over 4. Now look what we have. We have cosine square t, then sine t dt. Now, look inside the power. Same idea, guys. Look inside the power 2. What do you have? You have cosine. What's the derivative of cosine? It's negative sine. What do I have here, guys? I have positive sine. So what I can do here, simply, I can multiply inside by negative 1 and outside by negative. It's like I've done nothing, right? Because the negative can go in and out. The numbers can go in and out. So inside, I'm going to multiply by negative and outside by negative. Now, so what's this equal to? Negative 250. Now, look at this. The derivative of cosine is already complete. Its minus sign is there. So what's the answer? Cosine cube t over 3. Again, from 0 to pi over 4. Now, what do we do? So this is equal to negative 250 over 3. Take the 3 with the 2, all the constants out. Now let's plug pi over 4. So this is cosine cube pi over 4 minus, put the 0, cosine cube 0. And this is equal to minus 250 over 3. Cosine pi over 4, also 1 over root 2, all cube, minus Cosine 0, by the way, is 1. 1 cube is 1. So this is the answer. If you need to simplify it more, you will get 53.9 by calculator. This is 53.9. What if I need to integrate guys with respect to S? The whole curve. Look at the formula. I put it here down. You see, now this is the only formula you need to memorize. So this is why I put it there. So what do we say? So the integration of 2xy ds now over the curve C is equal to the integration of 2. X again is 5 cosine t. Y is 5 sine t. ds now. What's ds, guys? Remember S? It's the square root. Sorry. S here is the square root look what it says f prime, which means, by the way, we said this is f and this is g. So what's the derivative of that? It's minus 5 sine t square plus says now g prime. Then I'm going to go to g differentiate. The derivative of 5 sine is 5 cosine t all square, and then what? dt, because at the end there is a dt here. That's it. And again, the integration is from 0 to pi over 4. Now, what is this equal to? 2 times 5 times 5 is 50. So I'm going to take the 50 out. So this is the integration from 0 to pi over 4. Cosine t sine t. Now let's look inside here, guys. When you square this, what do you get? You get 25 sine square t, and this is also 25 cosine square t dt. And this is equal to 50 integration from 0 to pi over 4 of cosine t sine t square root of, I'm going to factor out 25, guys. So what am I left with? Sine square t plus cosine square t dt. But we all know that this is 1. So what am I left with? Square root of 25, which is what? 5. So 5 times 50 is 250. So 250. Now remember, all of this will end up to be 5. 5 times 50 is 250. Integration from 0 to pi over 4 of cosine t sine t. So let's put it this way. Sine t cosine t dt. Now notice that sine is raised to what power? 1. Why did I do that? Look inside the 1. You have sine. What's the derivative of sine? It's cosine. It's there, isn't it? So remember, so what's the answer? So this is 250. What's going to do? What's the integral here? So it's going to be sine squared t over what? 2. You see, because sine was raised to the power 1. Look inside the sine. You will see that it is equal to what? The derivative of sine is cosine, which is outside. So in this case, the answer is sine squared over 2. And this is from 0 to pi over 4. But this one with this one is 125, right? This one with this one is 125. So what do we have now? We're going to say, we're going to put the pi over 4. So this is sine square pi over 4 minus sine square 0, which is equal 125. We know that sine 0 is 0. Pi over 4 is 1 over root 2. So this is 1 over root 2. When you square it, what do you get? You get half. So the answer is 125 over 2. Okay, so this is, guys, how you integrate the function of two variables over xy or the whole curve C, which is ds. That's one way to do it. Now, If we can do this for function of 2 variables, then definitely we can do that for function of 3 variables, right? We parameterize it also. We let x equal f of t. We change y to g of t and z to h of t, another function. And then what if I need to integrate with respect to x? We go back to x. What's x? F of t, remember? So this x dx will be what? F prime of t. If I need to integrate with respect to y, same thing. We change x, y, z to f, g, and h. And then we differentiate y. What's y? Y is g of t. The derivative of that is here. So you place dy with g prime of t dt. Also now you can do it over h. If I need to differentiate with respect to z, z is h of t. So this is going to replace. And what's the derivative of dz? It's h prime, isn't it? H prime of t dt. And this is how you do it. If you want to do it over the whole curve S, what do we do? Same thing. It's the same. All I did is I increased by one function. So there will be h prime of t squared dt. It's the same as before. It's just a function of 3 variables. It's very silly, by the way. It's very simple. So here are examples of integrating these functions. So let me start with the first one. All of them, by the way, under this presentation. Okay, so this is the parameterization. So what do we say here with this one, guys? This is equal to the integration of 4 times x. Look at what is x here? T cube over 3. What's y? Y is t squared. You see, I'm parameterizing with respect to t. What's z? 2t. What's the x now? Look at this. X is t cube over 3. So dx over dt is what? 3t squared over 3. The derivative of t cube is a 3t squared. This 3 goes with this 3. You get what? T squared. Now bring dt here. So dx is equal to t squared dt. So this dx, guys, is t squared dt. And he's telling me that t is from 0 to 1. So this is from 0 to 1. And this is equal to now. 4 times 2 is 8. 8 divided by 3 goes out. The integration from 0 to 1. Now we have t cubed times t squared is t5. t5 and t1 is t6. t6 and t squared is t8 dt. And now what's the integration of t8? It's t9 over 9. From what? From 0 to 1. Now this is equal to 8 over, 3 times 9 is 27. Then it's t to the 9 from 0 to 1. And this is equal to 8 over 27. What do? We plug 1 first. We plug the 0 second. But 0 to anything is 0. 1 to 9 is 1 times this. So the answer is 8 over 27. This is the result of the integral. Now let's repeat this for y now. So this is 4. X is t cube over 3. Y is t squared. Z is here, 2t. Now the difference is in y. What's y in this case? Y is t squared. So dy over dt is equal to 2t. Bring this one here. So dy is equal to 2t dt. So this is 2t dt. Now let's multiply, guys. 2 times 2 is 4. Times 4 is 16, goes out over 3. And we are left, don't forget, this is from 0 to 1 again. T cube and t squared is t5. And t1 is t6. And this one, t7. So this is t7 dt. And this is equal to 16 over 3 from 0 to 1 again. This is t8 over 8 from 0 to 1. And what is this equal to now? So this 8 with 16 is 2. So we get 2 over 3 T8 from 0 to 1. So what do we do now? We plug the 1 first minus 0 second. And we know this is all 1. So this is 2/3. How about that one? Same thing. This is equal to the integration of 4xy. Sorry, I have to replace those with their values. X is t cubed over 3. Y is t squared. Z is 2t. Now, let's look at the derivative of z. Z is 2t. So what's the derivative of that? We know that dz over dt is 2. So that means dz is 2 dt. So this is 2 dt. From 0 to 1 again. So what is this, guys? 2 again, 8 over 3 goes out. Let's take it out. And the integration from 0 to 1, t cubed and t squared, t5, t6. That's it. So you have t6 dt. And this is equal to 8 over 3, t7 over 7 from 0 to 1. And this can be simplified as 8 over 21. If we multiply 3 by 7 is 21. So what am I left with? T7 from 0 to 1. You know, if you put the one, same thing, you get 1 minus 0, which is 1. So the answer is 8 over 21. Now let's go to the big shot here. So this is equal to the integration of 4 t cubed over 3. Y is t squared. Z is 2t. Now, what's ds, guys? It's the square root of what? Of the square of the first term. We have to differentiate this guy. It's what? This is f of t, right? So it's supposed to be f of prime. So now we have f of t is t cubed over 3. This implies that f of prime is 3t squared over 3, so which is t squared. So the answer here is t squared, all what? Square. This is f of prime, guys. The f of prime is t squared. Let's look at now g of t. G of t is this. It's t squared. What's the derivative of that? 2t. So we say here plus 2t all square. How about h of t? H of t, here it is, which is 2t. When you differentiate it, you get 2. So this is plus 2 square dt. And this is from 0 to 1. Let's see what we get from this complicated integral. 2 times 4 is 8 over 3 goes out. Now we have the integration from 0 to 1. T cubed and t squared is t5 and t is t6. Now let's look at the complicated thing inside. So this is t to the 4 plus 4t squared plus 4 dt. If you look carefully inside, what do we have here? By the way, this one, you can factor it to t squared plus 2 all square dt. This can be factored to t squared plus 2 all square. Right? T squared plus 2 all square. If I expand it, what do I get? The square of the first is t to the 4 plus the first times the second times 2, which is 4t squared, plus the square of the last, which is 4. There we are. So this is the factoring of this one. So what happens now? The square root cancels the square. So what am I left with? The 8 over 3 integration from 0 to 1 of t to the 6 times what? Times t squared plus 2 dt. What can we do here? We can expand it. So this is equal to 8 over 3 integration from 0 to 1. T6 times t squared is t8 plus t6 times 2 is 2t6, all of that dt, which is 8 over 3. Now, what's the integration of the first one? So I'm going to open a bracket. The integration of the first one is t to the 9 over 9 plus, what's the integration of this one? 2t to the 7 over 7. And this is from 0 to 1. What do we do now? We plug the 1 and then the 0. So this is 8 over 3. Let's put the 1 first. So you get 1 over 9 plus 2 over 7. Minus, you know, when you put the zeros here, you get all zeros, isn't it? If I put the 0 for t and 0 here, you get 0. So what's this? This is 8 over 3 times 1 over 9 plus 2 over 7. You simplify all of this and you can get actually 200 over 189. That's the final answer. All right. Now we finish with the first way of integrating a function of two variables. How do we do that, guys? By parameterizing the curve, by letting x equal f of t, y equal g of t in terms of two-dimensional. Three-dimensional, we let x equal f of t, y g of t, and z equal h of t. That's one way to do it. Now let's go back again to the function of two variables. Z equal g of xy, and I need to integrate it. What's the other way to do it, by the way? You can parameterize the curve by defining y as a function of x. Y as a function of x. Define y as a function of x, where x is going to be from a to b. If I do that, what's going to happen? The whole integral, instead of going like in the previous used to go to t, now everything would be function of what? Of x. So another way to do it is I parameterize the curve by letting y equal f of x. And x from a to b. If I have this, what's going to happen to the whole integral? It's going to change all in terms of x. I will show you how do we do this one in the 3 steps. Again, let's suppose that g is a function of x and y. What's the parameterization here says? It says let y equal f of x. So I'm going to just replace y with any function of x. So notice that everything here is a function of what? Of x. Okay, beautiful. Now, what's dx? I'm not touching x. I'm not doing anything for x. So it stays dx. Nothing. Okay, we're not going to differentiate it. So it stays as is. Because I'm only changing the y. And then x is from a to b. How about if I want to integrate with respect to y? Same thing. You replace y to what? F of x. But now, look, y is f of x. What's the derivative of y? It's f prime of x dx, right? So here is f prime of x dx. Case number 3. Remember, x doesn't change. What's the derivative of x? 1. So if I want to integrate with respect to s, the derivative of x is 1. Here it is. When you square it, you still have 1. What's the derivative of y? F prime. So f prime square, and then dx, and that's it. All I do is I change y to f of x, and then because do you remember ds? What's ds? It's supposed to be what here? This one is supposed to be what? F prime square plus g prime square. But I'm not touching f. Still x. What's the derivative of x? It's 1. So the derivative of 1. So this is why you see the 1 here. Who's changing y? Instead of gy is going to be replaced with f, so I'm going to put f prime square and finish it. Let me show you an example. Here's an example. I need to integrate all of this. So we need to integrate x y square dx over the curve c plus x cubed dy. This is the first time you see this kind of integral, right, guys? So you're going to get familiar, very familiar with this type of integration. All right, now, what do we do here? We are going to parameterize it where c is given by y equal x squared. So my curve here, guys, is y equal x squared. This is y equal x squared. But which part do I need from that? Only x from 0 to 1. 0, x up to 1. So here's the 1. You know what 1? We get 1. So I need only this curve. So I'm going to exactly specify where is my curve. My curve is going to be only this part. You see? This is now our curve C. This C that he's talking about. So I'm integrating this function, all of this, along this red curve only. Interesting. This is my curve that I'm looking for. So what do we do, guys? We do the following. We have x goes back where it was. So x, no change. But y is what now? Y is equal x squared. So this is x squared all square. I'm replacing y with x squared. Now what's dx? Remember, when we do that, nothing changed with x. Plus x cubed, no change. I'm just playing with y. dy. What's dy, guys? If y is equal x squared. So dy over dx is what? 2x. Bring dx here. So dy is 2x dx. So what's this dy? It's 2x dx. See what happened? Everything changed to x. And he's telling me that x is from what? From 0 to 1. So now this is the integral. And this is equal to the integration from 0 to 1. X to the, this is x to the 4 times x is x to the 5 dx. And here plus 2x to the 4 dx. But notice that they are all dx. So I can join them. So this is the integration from 0 to 1 of x to the 5 plus 2x to the 4. All of that what? Dx from 0 to 1. That's it. Now you integrate. Integration of x to the 5 is x to the 6 over 6 plus 2x to the 5 over 5. And this is from 0 to 1. What do we sub first? The 1. You get 1 over 6 plus 2 over 5 minus, if you put the 0, you get 0 plus 0. And the answer is the least common between those two is 30. 5 plus 12. What's the product? And this is going to be 17 over 30. This is the result of the integration, guys. Same thing. Now what we have here, now we finished the integration of the function of two variables over a curve. In how many ways we can do it? In two ways. Either we parameterize each x, y, and z to a function of t, or we just parameterize y as a function of x. If I have three variables, that's going to be difficult. We're going to postpone this one for y. But now let's go and see. Remember, I said if C is not a smooth curve, but it's a piecewise smooth curve. So what do? I can split the integral over both of them. Keep this in mind. And like the example we did a minute ago, if you are integrating this with respect to C and this again, you can join them in one piece. And this is, remember what I did in this example, right? This is what we did in this example. This one can be joined together. At the end, I joined them when I finished the integration and finished the whole thing. Okay. And here actually you can put them all in one piece if you like. So what he's saying here, if you have this kind of integral, a curve C of P dx plus Q dy, you can put it as one piece. And by the way, this is going to be the famous thing we're looking for. This is going to stay with us till the end of this chapter. P dx plus Q dy. This means a lot, by the way, in this course, in this chapter, actually. You will see in a minute. I don't want to just break the surprise. So I'm going to keep it till the end. All right. If you are integrating the function, the same function here, you see this one, over a closed curve. If remember the closed curve, start from a point and come back to the same point. If you're integrating a function over a closed curve, simple closed curve, what do? We put this sign. You see that sign here? Means our curve C is what? This is closed. So this is closed curve. I know it's closed from the sign that is there. Okay, guys? All righty. Now, let's come to the surprise. Do you remember in the previous sections, we defined f, if you have a function of x and y like this one, this is a vector what? Field. I know, now you remember, right? This is a vector field. R of t is a vector function, but f of xy, when it's p of xyi plus q of xyj, we call it a vector field. All right. Like, remember, we graphed the waves and the Rel pool and all these things we did in the previous sections. Okay, let's suppose that f is a vector field, and I'm going to parameterize it by letting x equal f of t and y equal g of t. So I'm going to have a curve that represents x and y. You know, those will be graphed. Remember, if you parameterize any curve, you still can graph it. We are integrating along the curve C, right? So we're going to integrate along the curve C. It take you a minute ago. Every time we integrate along a curve C. All right? So if I need to integrate along the curve C, and inside I have this f of xy, how do I do the integration? Now, I'm going to suppose my curve C is parameterized like this, f of ti plus g of tj, right? This is our curve C. This is called the position vector, right? Vector function. This is the position vector function. So you're moving along this one. Remember, we are integrating the function along the curve C. And if the curve C is parameterized, then it can be written as a vector function like that. All right, let's differentiate R, guys. What's the derivative of R with respect to t? It's the derivative of the first, which is f prime plus g prime. But again, f prime, f is x, so f prime is dx over dt, isn't it? It can be written like that. And g prime, if g is y, so g prime is dy over dt. So what do we have now? We have dr over dt, here it is equal to what? All of that, here's all of this. Now we are going to multiply all of this by dt. So what's going to happen? All of those are going to go away, and I'm left that with dr equal to what? dxi plus dyj. Now let me show you a trick here. You see this dr and this f. I will do f dr dot product. F, guys, I'm going to write it here. F dr. If I do dot product, what do I get, guys? Remember, how do you do the dot product? It's the first component times the first component. So what do I get? P of xy dx plus the second component times what? The second component, which is a q of xy dx. So what is this? F dot r, the vector field times the rate of change in the position. It's called the displacement. If I do that, what do I get? I get this one. So FDR, here it is. It's exactly this one. So this integral, remember in the previous, I told you this is going to be a famous thing. P dx plus q dy. This is P dx plus q dy is nothing but FDR. And I'm going to integrate it along the curve C. So what is F here? Let's look F as, in physics, remember that the force times the distance is equal to what? Work done, isn't it? We know the work is the force times distance. So this vector field is our force that is pushing. Once there is a displacement, so what did I do? So there is a work done on this one. So when you integrate this function along any curve, what did you just find? You just found the work done on an object moving along this curve using this force and with this displacement. So the work done, here it is, guys. This is what I need you to know. The work done on an object is FDR. And what's FDR? It's P dx plus Q dy. What are those P and Q? those are the force function, which is the vector field that will be given to you. All right, guys. So what are we going to do today? We are going to find the work done on an object if I was given the force, which is the vector field, and the R, the position function, the position vector function. Clear? So if I'm moving an object along a curve C, which is the position function, can I find the work done? Yes, simply multiply dot product the force by the derivative of that vector function, the derivative of the curve itself. Once you do that, you get the work done. So this is what we have, guys. The work done is FDR, which is P dx plus Q dy. Three-dimensional, same thing, P dx plus Q dy plus R dz. And this is, so you can move a function, an object on a curve in the XY plane, or it could be a plane flying on the three-dimensional space. I can always find the work done on an object, whether it's on the XY plane, on the ground, moving on the ground, or it's what? Flying on the space. And this is our topic, by the way, till the end of the semester. Our focus will be, guys, on these two formulas, the work done on an object. And they will not remain as simple as that. Okay, they will change in a minute. You will see later on, the more we go, things will change. So from now, you see, this is slide 30. From now on, everything is focused on the work done on object. So look, let me take you in the back a little bit. When we did this, by the way, what was answer? We did this example, right? We got 17 out of 30. You know what we just found? We found the work done, because this is, look, P dx plus Q dy. So what did we just found? We found actually the work done on an object moving on this curve C, which is y equal x squared. Let me go back to this graph, actually. So if I have an object, actually, that was here, and I moved it to there in this direction, the work done on this one is 17 over 30. I think it's called joule, right? The work is in joule unit. Remember that. So what did I just do? In this example, we just actually found that work done. All right, let's go back to more of this. Now we know this is our formula. Here's an example, guys. Find the work done by, look at this. This is our force function. And along this curve. So I need to move an object along this curve. I don't know how the curve looks like, and I don't care now, by the way, with using what? This kind of force. So what is the work done? Easy. Let's do it now. So what do we do first, guys? The first thing you have to do, you have to replace F. You know, F is what? I'm going to replace this X with, sorry, before I do that, so you won't be confused. Let me be more careful here with you guys. So we know that R of t, our curve is what? Ti plus t squared j plus t cube k. Remember, in three-dimensional space, this is who? This is x. So this is xi plus yj plus zk, isn't it? This is how it's usually defined, the parametric function. So, and by the way, this x means x of ti plus y of tj plus z of tk. If you have been following us from the beginning of the chapter, then you know what I'm talking about. So this implies here that this x of t is t, huh? So x is t. How about y? Y is the coefficient of j, which is t squared, and z will be replaced to t cube. This is the parameterized curve. So I'm going to go back to my first function, f of x, y, and z. I will replace everything with t. So look at this. It's e to the x. What's x now? X is t. So this is e to the t I plus x, which is t, e to the x times y. X times y, by the way, it's t times t squared, which is t cube, plus z. What's z? Z is t cube. Then what? E to the xyz. If I multiply t times t squared is t cube, and t cube is what? T to the 6. So look what I did. I changed, by the way, we forgot the j and the k. I changed my force function to a parametric force function. I parameterized it using the x, y, and x of t, y of t, and z of t. Now, what I'm going to do is the following. I'm going to find dr over what? dt. What's dr over dt, guys? What's the derivative of t? It's 1i plus 2tj plus what? 3t squared k. I just differentiated, which implies that dr, what's dr here? It's 1i plus 2tj plus 3t squared k. All of this what? dt. Now I'm going to find f dot dr, guys. F dot dr, which is what? E to the t I, sorry, plus t e to the t cube j plus t cube e to the t 6k. I will do this one, dot product with dr, which is 1i plus 2tj plus 3t squared k, and then dt. All right, let's multiply, guys. What do we get? The first by the first. 1 times e to the t is e to the t. Remember, I goes. This is dot product. It's scalar. Plus t e to the t cube times 2t is what? 2t squared e to the t cube plus t cube times 3t squared is a 3t to the 5 e to the t to the 6. This is FDR. And finally, what do we have? Don't forget, there is what? There is a dt. So FDR is there, guys. What does he want to find? He wants to find the work done, isn't it? Now ask yourself, what's the work done? It's the integration of FDR along the curve C, isn't it? Yeah, this is the formula. And FDR is already found. Here it is. It's e to the t plus 2t squared e to the t cube plus 3t to the 5 e to the t 6 and then dt. Now, in the question, did he tell me t from where to where? Yes, he did. Where t is from 0 to 1. Alrighty, now, how do we integrate those functions here? Okay, we know that this is equal to the integration, sorry. The integration of e to the t is what? E to the t, we know that. How about this one? And probably you can guess the last one. How do you integrate 2t squared e to the t cube? All right, dt. Usually, I'm going to take this one to be u. So here we let u equal to t cube. So du is equal to 3t squared dt. I have t squared dt. So I'm going to divide by 3. So du over 3 is t squared dt. So what's the answer for this one? So this integration will be what? Equal to the integration of, I'm going to leave the 2 by itself. Don't touch it. Now, e, this is e to the u. But what's t squared dt? T squared dt is du over what? Over 3. you can take the 2 over 3 out, and you are left with the integration of e to the u du. But we all know that the integration of this is what? E to the u, isn't it? Now what's u? U is t cube. So this is equal 2 over 3 e to the t cube. So the answer here for this one is plus 2 over 3 e to the t cube. Let me show you another way to do it. 2t square e to the t cube dt. Now let me show you something, guys. To integrate any exponential function, the derivative of the power must exist. What's the derivative of t cube? The derivative of t cube is what? It is a 3t square. Do I have 3t square? No, I have t square only. So what do I need? I need 3 inside. So look what we're going to do. To show you what the trick here, you can multiply inside by 3 and outside by 1/3. Look what I did. I multiplied inside by 2, by 3, and outside by 1/3. It's like I've done nothing. So I'm going to do the following now. I will kick this 2 out and the 1/3. So what am I left with? The integration of t square, as you see, this is t squared, that the square is for the t. Then e to the what? T cube dt, and I will put the 3 here. See, this is 3. I'm putting it in front of the t square. See what I did? I multiplied by 3 and I divided by 1/3. Then I don't need this. I moved it out. Becomes 2/3 because it's useless. But I kept this 3 inside and I put it in front of that. Look at this, guys. Isn't this the derivative of our power? Right? The derivative is there. Whenever the derivative of the power is there, so what's the answer? The answer is whatever outside here, just e to the t cube. If you have exponential function and the derivative of the power is there, that's it, you're done. Let me give you a simple example. What's the integration of e to the sine t cosine t dt? Look at this, guys. What's the derivative? The power of e is sine. What's the derivative of sine? Cosine. Is it there? Yes, that's it. So the answer is e to the sine t, and you're done. All right, so let's look at this last one, guys. Plus. So let's look at this one. What's the integration of 3t to the 5 e to the t to the 6 dt? Now ask yourself, what's the derivative of t to the 6? It's 5, it's 6 t to the 5, isn't it? Beautiful. So what do I need inside, guys? I need the following. The derivative of t to the 6 is 6t to the 5. So I need 6 here. So what I'm going to do, I'm going to multiply inside by 6 and outside by 1/6. Now, take this 3 out. You don't want it. So now you have a 3/6 integration. Put the 6 at the beginning. So this is 6t to the 5 e t to the 6 d6 dt. So what's the final answer? Look at this. So now, is the derivative of this ready? Yes, it is. So the answer is 3/6, by the way, is half. Since the derivative of the power is available, so the answer is e itself, e to the 2/6, and you're done. So this is the answer. So the answer here plus half e t to the 6. And this is from 0 to 1. Now what do? We plug the 1, guys. So this is e to the 1 plus 2/3 e to the 1 also, because 1 cube is 1, plus 1/2 e to the 1 minus, what do you plug now? 0, e to the 0 minus 2/3 e to the 0 minus 1/2. Now this is 1e and 2/3 e and 1/2 e. So I'm going to do this calculation here. You have 1 plus 2/3 plus 1/2. What's the least common between all of those? It's the 6. 6 times 1 is 6, plus 6 divided by 3 is 2 times 2 is 4, plus 6 divided by 2 is 3 times 1 is 3. So the answer is 13 over 6. So this is going to be 13 over 6e. Now let's look at this one. I can factor out the minus. So what's left? E to the 0 is 1 plus 2/3 plus 1/2. It's the same thing, isn't it? Which is equal to 13 over 6e minus 13 over 6. You can take 13 over 6 out, so you're left with e minus 1, and that's the final answer for this question. After that, my job is up to here with you guys, is up to here just to set up the equation. After that, this all goes to calculus 1 and calculus 2. And that's the answer. Let's do this question, guys. Similar idea. What do we have? We start always with RT. He wants to find the work done. You do first look at R of t. It's e to the minus 2ti plus e to the tj. This is only between two-dimensional space. And this can be written as xi plus y what? J. So what do we conclude from here? That this x is e to the minus 2t, and y, the coefficient of j is e to the t. Beautiful. Now what do? We go back to our f. By the way, there is no z here. So this is, so f of x and y is equal to what? Y cube. What's y? Y is e to the t. So this is e to the t cube I minus x squared. X is this. So e to the minus 2t squared. And then what? Y. What's y? E to the t. All of that j. Now, what's e to the t cube? You know, when you have a power raised to a power, you multiply them. So this is e to the 3ti minus. Same thing here, you multiply 2 with negative 2, you get e to the minus 4t times e to the tj, which is equal e to the 3t minus. Now, when you multiply, you add the powers. Minus 4 plus 1 is minus 3. So this is e to the minus 3tj. This is, guys, the parameterization of f in terms of t. So I changed it from xy to t. Now, what's the next step? We differentiate r, the derivative of that. What's the derivative of this? Or you can say, instead of that, you can say dr over what? dt. Let me be more precise so you follow the same steps. What's dr over dt? The derivative of the exponential function is the exponential function itself times the derivative of the power. What's the derivative of e to the minus 2? It's minus 2i. This is by chain rule, if you remember. Plus, what's the derivative of e to the t? E to the tj. Now bring dt here. So this implies that dr is minus 2 e to the minus 2t I plus e to the tj, all of that dt. Now what do? I need to find the work done. So what do we do now? F dot dr. Where is f? This is f, guys. So e to the 3ti, I forgot the I, minus e to the minus 3tj, dot product with dr, which is minus 2 e to the minus 2ti plus e to the tj and dt. All right, guys, let's multiply. The first times the first, you get negative 2. Now, when you multiply, you add the powers. E to the 3t minus 2t. So 3t minus 2t is t. So this is e to the t. Then what? The second times the second. Minus, here is minus. E to the minus 3t times e to the t is e to the minus 2t. That's it. This is FDR. And then you have dt at the end. So you put what? dt at the end. This is, guys, FDR. So now what do we say? The work done is the integration over the curve of what? FDR, which is the integration of minus 2 e to the t minus e to the minus 2t dt. Now, since everything changed to t, he's telling me that t, instead of this going to c, we say t from 0 to ln 2. And this is equal to, what's the integration of e to the t? It's e to the t. So this is minus 2 e to the t. All right, guys. Now, what's the integration of this? Remember, we need the derivative of that. Okay, so look at this. What's the integration of e to the minus 2t dt? I said I need the derivative of that. What's the derivative of this? Minus 2, that's easy. Or if you like, let's do it by substitution. You let u equal minus 2t. So what's du over dt? It's negative 2. Bring this one here. So du is minus 2 dt. But I have only dt. So du over minus 2 is dt. So what's my question going to be? It's going to be e to the, I took this one to be u. And what's dt? du over negative 2. Take the negative half out. And now you have the integration of e to the u, which is negative half. The integration of e to the u is e to the u, which is negative half. What's e to the u? Minus 2t. So this is going to be minus, the integration of that is minus half e to the minus 2t. And this is all from 0 to ln 2, guys, which is equal, actually, minus 2 e to the t. Minus with minus is plus 1/2 e to the minus 2t. Now from 0 to ln 2. Now what do we, guys? We plug ln 2. So this is negative 2 e to the ln 2 plus half e to the minus 2 ln 2. Then what do we say? Minus, open bracket, put the 0, negative 2 e to the 0 plus half e to the 0, which is equal to negative 2. We know the e cancels the ln, so we have 2 plus half. This can be written as ln to the 2 to the minus 2. I can bring the power up there. Minus. This one is negative 2 plus half, which is equal to, this one with this one is negative 4 plus half. What is this? E cancels that. You have 2 to the minus 2, which is what? 1/4, right? So plus, so times 1/4, right? This is 2 to the minus 2, which is 1 over 2 squared, which is 1/4. Minus, now minus 2 plus half is going to be minus 3/2 times minus, so plus 3/2. And this is equal to minus 4 plus half plus 1/8 plus 3/2. The least common between all of this is 8, as you know. 8 times 4 is 32, so minus 32 plus 1 and plus 8 divided by 2 is 4 times the 3 is 12. So this is minus 31 minus 21 minus 20. You make sure here, 13. So we have minus 32. So 19/8. Make sure we get the right answer. We don't have a question. So this is the answer for this question. Let's do this question now, guys. I need to integrate this one. Look at the sign here. There's a hint here. This is a closed curve, over a closed curve. where C is this one. Do you think this is a closed curve, guys, from 0 to pi? Look at this one. X is equal 5 cosine t, and y is 5 sine t. If I square both of them, by the way, and add, so what's x squared plus y squared equal to? It's going to be 25 cosine squared plus 25 sine squared. Take 25 out, so you get 25, and we did it a minute ago, by the way. So what do we have here, guys? We have a circle of radius 5, isn't it? And he's telling me that t is from 0 to 2 pi. So this is full rotation, isn't it? So do we have a closed curve? Yes, we do. So we start from here and we go in this direction, by the way. You keep on and you come back here. So what's happening? You're carrying an object, starting from here from 5. You go all the way on the circle and you're going to come back. We are going to measure the work done on an object that has been moved on this circle, starting from 0 all the way to 2 pi. Makes sense, right? So this is nice understanding of what's going on with the work done. All right. Now, how do you do this, guys? So let's look at S now. So what do we do now? We have, so the integration of the closed curve C of x squared minus y squared ds is equal the integration. Replace x with what, guys? With 5. So we have 25 cosine squared t minus y squared is 25 sine squared t, close. Remember what's ds, guys? It's the square root of the derivative of the first square. The derivative of that is 5 sine. So this is f, by the way. The derivative of that is minus 5 sine t squared plus the derivative of this is g, it's 5 cosine t squared, then dt, and t is from 0 to 2 pi, so I can say now this is from 0 to 2 pi. And this is equal to the integration from 0 to 2 pi. 25 can be factored out from here. So what am I left with? Cosine squared t minus sine squared t. Now let's go here, guys. This is the square root of. You square this one, you get 25 sine squared t plus 25 cosine squared t dt. I can here factor out 25. So what am I left with? Sine squared t plus what? Cosine squared t, isn't it? Now, but we know that this is 1. So the whole thing is what? All of that is 25. So what's the square root of 25? It's 5. So all of this, guys, is nothing but 5. So this is equal to this 5. If I multiply it by 25, what do we get? We get 125 goes outside, 0 to 2 pi of cosine square t minus sine square t dt. Now the question is, how do you integrate this one? There's a nice formula for this one, by the way. 0 to 2 pi. Remember from calculus, cosine square minus sine square. One of the formulas of this is cosine 2t dt. Now, what's the integration of cosine? We know it's sine, but the problem is the derivative of this one is 2. Remember, to integrate any sine or cosine function, you need the derivative of the angle. What's the derivative of this? 2. Do I have 2 inside? No, that's easy. Just multiply inside by 2 and outside by half. Divide by 2. So I multiply inside by 2 and outside by 2, by half. So what do we get, guys, from this one? So we get 125 over 2. The integration of cosine now is sine the angle. Now I can integrate it. Why? Because I provided the derivative of the angle. If it's there, that's it. Integrate normally. All right? And this is what? From 0 to 2 pi. Let me give you another example. If I say, what's the integration of cosine x squared, then 2x dx. Look at this. What's the derivative of x squared? It's 2x. Is it there? Beautiful. So the answer is sine x squared. Done. You don't have to do much. So keep this in mind. Now this is equal to 125 over 2. What do we do now? We plug 2 pi. So this is going to be sine, if I put, we get 4 pi minus sine 0. By the way, sine 0 is 0. Sine 4 pi is also 0. So what's the final answer? 0. So the work done to move an object on this circle and come back is nothing. It's like no effort being done here. And I have no idea why. Maybe there is no friction in the air. There is nothing there. He didn't put any effort. Just moved it back. Let's look at this one. Now, definitely, this is a work done because look at what you have. Look at this. This is P dx plus Q dy, isn't it? So this is what we're doing now. We have an object starting from here, and it's gonna move in this direction as you see, and then it's gonna come back here. I need to integrate over this closed curve. What's wrong with this curve? Big problem with this curve is that this is not smooth, but from here to here, from here up to here, this is gonna call C1, and this is smooth, isn't it? Then when he comes back, he's gonna come back with what? With a different path. So coming back is going to be from here back. In this, I'm gonna call this one the second. Also, this is what? Smooth. So what we're gonna do is the following. I will say, look at C. So C here consists of C1 and what? And C2. Fine? So what's happening? So the integration over this closed curve C of x squared plus y squared dx minus 2xy dy is going to be split to 2 parts, and I'm not going to put the closed curve anymore. So it's this integration over C1 plus integration of what? Of C2 of all of this. All of this is going to come here and is going to come here. So I split it, and I'm not going to put the closed sign. Why? Because the first curve C1 is not closed and C2 is not closed. Now, what's your job is to define what is C1 and C2. Since C1 is red, so let's go to C1, guys, and see how can I define C1. Let's look at C1. What do we have in C1? Look how this curve is parameterized. Y is equal to what? X squared. So y is equal to x squared. And what's x here, by the way? If you look carefully at the graph, x is what? 1. So to move from here to here, x is going to start from 0 all the way what? To 1. So here x is from 0 to 1. And y is x squared. So now we're going to go to the integration. So the integration over C1 of this, I'm going to take that part of what? Of x squared plus y squared dx minus 2xy dy is equal to the integration of x squared. X is not going to change, plus, but y is going to change. What's y equal to? X squared. So this is x to the what? 4, because y is x squared, but y is squared, so this is x to the 4. All of that what? Dx minus 2x. What's y now? Y is x squared, then dy. What's dy, guys? Look at this. From here, if y is equal to x squared, so what's dy over dx? The derivative of x squared is 2x, right? Move now dx here. So dy is 2x dx. So this is all multiply by 2x dx. Since everything is in terms of x, remember x here is what from where to where? From 0 to 1. So I'm going to integrate from 0 to 1. And this is not a closed curve anymore. What is this equal to? The integration from 0 to 1. Look what I'm going to do. This is x squared plus x to the 4. Join them. What is this? X times x squared times x is x to the 4, 2. So minus 4x to the 4 dx. This with this will be one piece. So this is 0 to 1 of x squared minus 3x to the 4 dx. Now it's easy to integrate, isn't it? What's the integration of x squared? It's x cubed over 3 minus 3x to the 5 over 5. And this is from 0 to 1. Put the 1 first, you get 1/3 minus 3/5 minus, if you put the 0, you will get nothing but 0. The least common, by the way, between 3 and 5 is 15. 15 divided by 3 is 5. 5 times 1 is 5. And 3 times 3 is 9. So the answer is negative 4 over 15. This is joules, the work done in joules. By moving the object from 0 to, so there will be negative effort. There's a lot, going up here. Now let's go to the second one, guys, which is the green one now. I'm going to go to the green one since I put it in green form. Now, what's the integration? Along the curve C2. So, of what? Of x squared plus y squared dx minus 2xy dy. All right. So what do we have here about C2, guys? What do we know about C2? C2, the function that's going back. What function is bringing me back? It's root x. So this is y is equal to root x. And x from where to where? Be careful. When you go here, so x from what now? From 1 to what? See, this point is 0 and 0. So x is going to go from 1 to 0. So x from 1 to 0. It's kind of weird to write it this way, so I'm going to think of it and write it in this way. Where x is from 0, so from 1 to x equals 0. All right, so what's going to happen now? I'm going to integrate over C2. Let's go back. It's x squared plus, here it is, by the way, y squared. What's y? Y is root x all square, then dx. Minus 2, x, we don't touch it. Y is root x. Then what? dy. Let's go back here, guys, and find dy. If y is equal to this, so what you know what dy over dx? This is what? 1 over 2 root x, if you remember that. So that means dy is 1 over 2 root x dx. So this is dy, guys. So 1 over 2 root x dx, this is dy. And we know in the second one, x is from where? From 1 to 0. X goes from 1 to 0. Now what happens here? This 2 root x goes with this 2 and root x. So what am I left with? The integration from 1 to 0 of x squared plus what? This one is x minus x dx. This one cancels that one. So I have to integrate from 1 to 0 of x squared dx. But remember, in calculus, you cannot integrate from big to small. It has to be from 0 to 1. So what do I do to flip? We put a negative sign, 0 to 1 of x squared dx. You have to do this first. And the integration of x squared is x cubed over 3 with a minus from 0 to 1. What do we plug first? The 1. So the answer is negative 1/3. So along the second curve is minus 1/3. So therefore, the integration of my question, closed curve C of x squared plus y squared dx minus 2xy dy is what? It's the first result we got, which was, where's the red one? Here it is, minus 4/15 and minus 1/3. We can multiply this one by 5 and here by 5. So what do we get? We get minus 4/15 and minus 5/15. And the answer is minus 9/15 joules. This is the work done on this object. Let's see what's happening here, guys. Okay, we have to integrate this. We know that this is, it looks like this is P dx plus Q dy. So definitely this is FDR. This is the work done. What is the work done in moving object along this? So I know that this is FDR. So the inside here, everything here is FDR, F dot dr. I know this is a work formula. Where C is the movement from minus 1, 2, all the way to 2, 5, guys, along this path. Notice that this path is not smooth. So what do we do, guys? So we say that the integration along C, and there is no close sign because this is not a closed curve, of all of this is equal to what? The integration along C1 plus the integration along C2 plus the integration along what? C3. So now let's see one by one, guys. Let's look at C1. Let's define C1. What do you see with C1, guys? What I see in C1 is that x is always fixed at where? At -1, isn't it? No matter where you are here, x is -1. How about y? Y starts from where, by the way? Y starts from where? From 2 all the way to what? What is this y? 0, right? And y is from 2 to y equal to 0. From 2 to 0. Okay, fine. If x is -1, do you know what's dx, guys? What's the derivative of that? We know it's a 0, isn't it? Okay, now we go to our question. So the integration along C1 of 2x plus y dx plus xy dy. What is this equal to along C1? Along C1, we know that x doesn't change. X is what? -1. So this is 2 times -1 plus y. I don't know what y is, so I'm not going to touch it. Then what? dx. We know that dx is what? Is a 0 plus x, which is -1, times y. I have no idea what y is. Times dy. I don't know what's that. So dy stays. So here we are parameterizing with respect to x, not with respect to y. Since everything is in terms of y, you see, notice everything is in terms of y. Y is from where? Y is from 2 to 0. Be careful. It's from 2 to 0. All of this is going to die. Why? Because it's multiplied by 0, guys. So what am I left with? I'm left with the integration of minus y dy from 2 to 0. And as you know, I don't like 2 to 0. So what should we do? Flip it. So it's from 0 to 2. It has to be from the small to the big. And when you do that, you change the sign so it becomes y dy. Now the integration of y is y squared over 2 from 0 to 2. Put the 2, you get 4 over 2 minus 0, which is 2 joules. So to move the object from this top point down to the ground, it will take you 2 joules. It's positive. Let's move it now. Same object from here to here along C2 now, guys. So I will change and go with different color. Let's define C2, guys. What's C2 here? What do you notice in C2? C2, x starts from -1. By the way, this point is 2 and 5. As long as you are in C2, you know that y is what? You are on the x-axis, so y is 0. And x is changing between -1 and what? And 2, isn't it? Along C2. So I know from this one that dy will be what? Will be 0. The derivative, so if y is 0, so the derivative is 0. So now I'm going to go back to my integration. So the integration along C2 of what? Of 2x plus y dx plus xy dy is equal to the integration. Now who's going to change the y? Y is 0. So this is 2x, x no change in it, plus y is 0. Then dx plus x, done, no change. Y is 0 and dy is also 0. So all of this goes away. I'm left with the x. Look at x. X is from where? From -1 to 2. So what am I left with? So this is the integration from -1 to 2 of 2x dx. And we know that the 2 goes out. The derivative of x is x squared over 2. So the answer is x squared from -1 to 2. The integration of x is x squared over 2. The 2 goes with the 2, and you're left with x squared. Now what do? We plug the 2 first. So what do you get? 4 minus. Plug the -1. -1 squared is 1, and the answer is 3 joules. You need more effort to push it. Less effort, you see, to bring it down. Just 2 joules. Here, you need 3 joules to push it on the ground because there's a friction. Oh man, look now. C3, there's more effort. You have to push it up. Right? So let's see what we get with C3. So I think I have the next page for that. Yeah. Let's look at C3 now. So I'm going to change the color for the C3, and it's going to be blue. Let's look at C3, guys. What do you notice in C3? Y is changing. By the way, this is Y what? 0. By the way, this is X. X is 2 and Y is 0. So on this line, X is always 2, as you see. You see, it's 2 and here it's 2. So here we know that X is always 2. But Y is changing between what? 0 and 5, isn't it? So here we know that X is fixed at 2, but Y is changing between 0 and 5. And by the way, when X is 2, so what's dx? The derivative of that is 0. So now let's integrate our function 2x plus y dx plus xy dy along C3. What do we get, guys? So this is the integration. X is 2. So this is 2 times 2 plus y. I have no idea what y is, but dx is what? Is a 0. This dx is a 0. Plus x, which is 2, times y, which I don't know what is it. Then what? dy. Since everything you see, this is going to go away. This is 0. I'm left with function of y. Y is from where? From 0 to 5. So what do we have? We have the integration from 0 to 5 of 2y dy. And we know the integration of y is y squared over 2. The 2 goes with the 2. So you have y squared from 0 to 5. If you put the 5, you get 25 joules. You see how much effort you need to push it up? Really, a lot of effort to bring it up. The lowest is bring it down here on the elevator. Going down, that's easy. To push the elevator up is really hard. So now, what's the final thing, guys? So the integration of C of 2x plus y dx plus xy dy is equal to what, guys? It's equal to the first path. What did we get for the green? We got 2. So it's 2 plus the 3. So it's 2 plus 3. Here there was 2 joules. Here 3 joules. And here what? 25 joules. So plus 25. And this is 30 joules. So to bring the object from -1, 2 all the way to 2, 5 up, it's going to take me 30 joules. And this is how you spell it. All right, let's look at this function, this integration. I need you to integrate this. By the way, this is P dx plus Q dy plus R dz. Remember, this is also what? This is F dr. It's a work done. He wants to integrate this along this from 0, 0. Now, this is weird, to 2, 3, 4, and then from 2, 3, 4 to this. So I have two paths. Here is path number 1. And here is path number 2. I'm not sure if we can graph that one. I will do my best with that one. Say 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Let's look at the first point. The first point is 0, 0, guys. So I'm going to change the color now to see what our paths. First, you're going to go from 0, 0, 0. This is it. To where? 2, 3, 4. How do we graph 2, 3, 4, by the way? You go 2 to the x-axis, 3 to the y-axis, and what do you make? You make those lines. So now you are on the ground. Huh? So this point is what? Is only 2 and 3. This point is 2 and 3. Now, how do you go to 4 to z? This is 4z. From y, you go all the way up to z, 4. And then you take this line down, and then you go up here and see where they meet. They meet here. So what do I do now? I'm going to remove everything. I don't want anything in front of me. So I don't need this. We don't need those things. All right. I don't need that. All I need is the following. So the first path, guys, is going from here, from here to here. This one is C1. What is this point? 2, 3, and 4. Now the next path is going to be from 2, 3, 4 to 6, 8. So I'm gonna change the color to see what is the other path. Let's take the green one. 6, 8, 5. Where is it? X is 6. This is 2, 3, 4, 5, 6. Here is 6. Y is 8. We know this is 8. So what do I do from there? We take a line parallel to the x-axis. And from here, a line parallel to the y-axis. They meet here. What is this? This is 6 and 8 only. How do I go up to 5? Here's 5 on the z-axis. From the y, you go all the way up to 5. Then you go take a line parallel to the x-axis. You go all the way up here. So they meet there. So what I'm going to do now, I'm going to remove all of those extras. If you can see the video, you know what's that. You can repeat it, but I don't want to mess up things. So this is what we have. I do that. Now what's going to happen? There is another path. What's the other path, guys? He's going to go from this point to this point. This way. So this is C2. The green one is C2. So what we're going to do, let's define both of them. So I'm going to go back to the red one, which is C1, and see how can we define it. Here's C1, guys. C1 goes from where? From 0, 0, 0 to 2. So 0 will move to 2, right? 0 is going to go to 2. All right? So what's going to happen? I'm going to let x, so here I'm going to let x to be 2t, where t starts from 0 all the way to 2, isn't it? Look, if we put 0 here, I get x0. Put t2, you get x2. Sorry, not 2, but 1. My apology. Put t0 here, you get 0x. Put t1, what do you get? x2. So this will take you from 0 to 2. Now let's look at y. Again, from 0y to what? To 3. Y, this is for y. From 0 to 3, this is y. This is x. Okay, so what do you let y equal to? 3t, where t is between 0 and 1. Make sure that t is always the same. How about z, guys? Z goes from 0 to 4. So from 0 to 4. So I'm going to let z equal to what? 4t, and t is between 0 and 1. And this will take z from 0 to 4. Interesting. So what do we have in our work? Now I can go back to my question. So the integration along the curve C1 of y dx plus z dy plus x dz is equal to the integration. Everything must change to t, by the way. What's y here? Y is a 3t. So this is a 3t times dx. Look, guys, I'm going to continue here and say, what's dx? What's the derivative of this? Isn't it 2 dt? So dx here is 2 dt plus, let's look at z. Z is 40 times dy. What's dy here, guys? dy, the derivative of 3t is a 3 dt. So this is a 3 dt plus, what's x? X is 2t. So I'm going to replace it with 2t times dz. What's dz from this one? dz is what? 4 dt. Because dz over dt is 4. So dz is 4 dt. So this is 4 dt. Since everything changed to t, and I know all of them are t from 0 to 1, so we say from 0 to 1. Now the first one will be integration from 0 to 1 of 6t dt plus 12t dt plus 8t dt, which is the integration from 0 1. You see, they are all the same. 6 and 12. So 12 and 8 is 20. So this is 26 t dt, isn't it? They're all the same. Now, what's the integration of that? It's 26t square over t. The integration of t is t square over t from 0 to 1. But 26 divided by 2 is 13 t square from 0 to 1. If you put the 1, you get 1. Put the 0, you get 0. So the answer is 13 joules to move the object along C1. Now let's go to C2, guys. What do you see on C2? C2, the point here is 6, 8, and 5. So where am I starting with? I'm starting with 2. So x starts from 2, goes to what? To 6. So I'm going to let x equal what? 2 plus, how much is the increase? From 2 to 6 is 4. So plus 4t, where t is between 0 and 1. How about that? Put t0, you get what? 2 plus 0, which is 2. Put t1, 2 plus 4 is 6. So this is how it goes. And I know that in this case that dx is what? The derivative of that is 4 dt. Now let's look at y, guys. Y is going to start from 3 to 8. Y is from 3 to 8. So I can define y to start from 3 plus what? 3 to 8, how much is the increase? 5. So this is 5t, where t again is between 0 and 1. Really? If you put t0 here, you get what? 3. Put t1, you get 8. So this makes sense. So I know now in this case that dy is what? The derivative of 3 is 0. The derivative of 5t is 5 dt. Let's look at the z, guys. Z here goes from 4 to 5. Increase of 1 only. So z goes from 4 to 5. So I can define z to be what? The start point plus only 1t, isn't it? And t is between 0 and 1, because the increase here is only 1. So dz is equal to 1 dt, because the derivative for 0, the derivative is 1 dt. Done. So what do we conclude from all of those? That the integration along C2 now of y dz, y dx, plus z dy, plus x dz is equal to the integration. Y, what's y, guys? Y is 3 plus 5t. So it's a 3 plus 5t times dx. What's dx? 4 dt. Plus z, which is 4 plus t, times what? dy. What's dy? 5 dt. Plus x dz. X is 2 plus 4t times dz. dz is dt. There you are. Along, and t is what? From 0 to 1. So now what do we have, guys? We have the integration from 0 to 1. Multiply. 4 times the 3 is 12 plus 20t. Let's go here. You see, I'm not going to put the dt. I'm going to put it at the end because they're all dt. 5 times 4 is 20 plus 5t. See, I multiply the 5 by the 4, and I then multiply by t. Here, nothing. So plus 2 plus 4t, all of that dt, which is equal integration from 0 to 1. Now let's add the numbers, guys. 12 plus 20 is 32. 32 plus 2 is 34. So this is 34 plus 20t, and 5t is 25t, and 4 is 29t dt, which is equal to, now the integration of 34 is 34t, plus the integration of t is 29t squared over 2, and this is from 0 to 1. And if you do this, you get what? Put the 1 first, you'd get 34 plus 29 over 2. Put the 0, you get 0. So this is what you have. 34 times 2 is 68 plus 29 divided by 2. 9 and 8 is 17. 3 and 6 is 9. So this is 97 over 2. This is the second joules. So now what's the work done, guys? So now we can use the final answer. Let's change it to this purple. I'm going to put the answer here all together. So we can say that the integration along the whole curve C of y dx plus z dy plus x dz is equal to the integration along C1, right? Plus the integration along C2. And the integration along C1, we got 13 joules, plus the integration of this one is 97 over 2. Multiply 13 by 2, you get 26 plus 97 divided by 2, which is equal to 7 and 6 is 13. This is 120 over 2. That's the answer, guys. Joules. This is how much it takes to move the object along these two paths, the red one and then the green one. Let's look at our last example. I'm trying to include as many examples so you get the idea of how do we do the line integral and how do you find the work done. Does this one represent a work done? Of course it is. Why is that? This is P dx, as you see, plus you can say minus 2xy dy. So this is a q dy. So this is definitely a work done. Look at the sign. I have a closed sign, means my path is closed. So I need to deliver the object starting from here, going up to here, then going on the circle. So this path is not smooth, right? So I'm going to call this one C1, and I'm going to call the next one C2. C1 is smooth and C2 is smooth. So let's look at C1, guys, the easy one. Which color is C1? The pinkish. So let's take this one. So C1 is, what do we have in C1, by the way? This point, by the way, is -2 and 0. And this is 2 and 0. You can tell that because I have a circle of radius 4. So the radius is 2. So this is -2 and 2. He didn't put it, you have to put it down. So as long as you are on this path, we know that y is what, guys? We know y is 0, right? You are on the x-axis, y is 0. So definitely dy is what? Is also 0. Also on this path, x goes from where? From -2 to 2. So now I'm going to integrate along C1 my function x squared plus y squared dx minus 2xy dy equal to the integration. What's C1 here? Let's look at it. Y is 0 and x doesn't change. So we have x squared plus y is 0. So this is 0. Then dx minus 2x times y, which is 0, times dy, which is 0. So all of this goes away. I'm left with dx. And x, you see, is from where? From -2 to 2. So what am I left with? The integration from -2 to 2 of x squared dx. And what's the integration of this one? It's x cubed over 3. And this is from -2 to 2. Put the 2 first, guys. What do we get? We will get 2 cubed, which is 8 over 3, minus, put the -2, you get -8 over what? 3. So top minus the bottom, which is going to be 16 over 3. Altogether, 16 over 3 joules to move an object just from this point all the way to this point. Now let's go to the circle. In the circle, you can't really define x and y. So the best way, since I have a circle, remember, now I'm going to go to the red one. What do I notice? C2 is a semicircle, right? The best presentation for this one is we let x equal to what? Because this is a circle of radius 2. So I'm going to let x equal to what? 2 cosine t. And y equal to sine t. Look what happened when I square them, guys. If I square, I add, what do I get? X squared plus y squared. What's the square of this? This is 4 cosine squared 2. And the square of the second one is 4 sine squared 2. And this is what? 4 out. You're left with cosine squared plus sine squared, which is 1. So it's 4. So what do you have? So you have x squared plus y squared equal 4. And that was actually our function, isn't it? So this is semicircle, exactly. So that what I'm going to do, I'm going to parameterize it with these two guys. Now, ask yourself, t is from where to where? If I'm going to start from here, this theta is 0. If I'm going to go all the way on this curve to here, how much angle did I make? You know, this is pi, isn't it? So this is from 0 to pi. Interesting. Now we go to our work. Before I go there, if this is x, guys, so what's dx? It's -2 sine t dt, isn't it? That's a derivative of 2 cosine. dy, if you differentiate this, this is 2 cosine t dt. So now I'm going to go back to my question and integrate it along C1. X squared plus, sorry, C2. X squared plus y squared dx minus 2xy dy. What is this equal to? The integration. Now, it's obvious that x squared y squared is what? Is 4. It's given to me, right? So I don't have to worry much about it. So this is 4. Then what? dx. What's x, by the way? X is 2 cosine t. So times 2 cosine t, right? This is, my apology, I need dx, not x. Probably I'm getting tired. Okay, here it is. dx, here is dx. It's minus 2 sine t 2t. It's my negative 2 sine t dt. Now, minus 2 times x. What's x? X now is here, which is 2 cosine t, times what? Times y. Y is here, 2 sine t, times what? Times dy. What's dy? It's 2 cosine t. And then dt, which is from 0 to pi. Everything's changing to t, as you see. Now let's look at this one. Negative 2 times 4 is negative 8. So the answer is the integration from 0 to pi of negative 8 sine t dt. Minus, let's look at this one. 2, 2, 2, and 2, that's 16. Now we have 2 cosines, so this is cosine square t sine t dt. All right, now, what's the integration of this one, guys? The integration of sine is negative cosine. So this is equal to negative. So it's going to be positive 8 cosine t. The integration of sine is negative cosine, and there is a minus, so it becomes positive, and you already have an 8. Now let's look at this one, guys. What's the integration of cosine square t sine t dt? Now look at this, guys. I remember the idea. I have a power function. Look inside. What do you have? You have cosine. What's the derivative of cosine? The derivative of cosine is negative sine. So this is, or let's do it this way. Let u equal cosine t, because the power is carrying the cosine. So du is minus sine t dt. But in the question, I have sine t dt. So I'm going to do so minus du is sine t dt. All right, so let's go back to the question. So what's the answer here? So this is the integration. I took the cosine to be u, so this is u square. And what's sine t dt? Sine t dt is minus du. Here's a minus and du. So the answer is negative u cubed over 3. But what's u? U is cosine. So the answer is negative cosine cubed t over 3. So the minus 16 goes out, and the integration of this is negative cosine cubed t over what? Over 3. And this is from 0 to pi, which is equal to 8 cosine t plus 16 over 3 cosine cube t, and this is from 0 to pi. Now, what do you plug first? The pi, guys. So this is going to be 8 cosine pi plus 16 over 3 cosine cube pi minus 8 cosine 0 minus 16 over 3 cosine cube 0, which is equal to, by the way, cosine pi is negative 1. So this is negative 8. Same thing here, this is negative. Negative cube stays negative, so minus 16 over 3. This one is minus 8. Cosine 0, by the way, is 1. So this is minus 8. And cosine 0 is 1, so minus 16 over 3. Minus 8 and minus 8 is minus 16. And minus this and minus this is minus 32 over 3. 3 times 16 is 30, 40 what? 48. So negative 48 minus 32 over 3. And this together, 10 and 70 is minus 80 over 3 joules. All right, guys. So this is the work done on this object using this formula. Do I have any more? I don't think we have any more. All right. And that's, guys, the end of this one. I hope you enjoy it. So if there's an error, anything, please let me know. You can always email me for feedback. And then this will take us to the next. Now we're going to keep in mind that we are always dealing with the work done. And now we understand how to integrate function of two variables over a curve. And from there, I took you, by the way, to integrate a function over a curve, the curve has to be parameterized in two ways. Either you change it to functions of t, or you let y equal f of x. Then we defined what is the FDR, the work done, and then we started finding, or every time we find the work done on an object. All right? All right, we see you in the next video. Have a good day, guys. Bye.